Hello all. Let's welcome Dmitry, who will present Russian crypto algorithms in the open source world.
Good morning. Yeah, that works. I will be speaking about the Russian crypto algorithms. Some of you may probably know the word GOST. Some of you have visited the Red Hat Dev conference where one of my colleagues was speaking about the GOST crypto algorithms in the OpenSSL and the requirements and the needs to support them. So I'm a software engineer, of course. I work in the mostly in the embedded Linux world, working now for more than 14 years. And unlike another Dmitry, GOST crypto algorithms started initially as a hobby time project for me. Unlike Dmitry, I'm not affiliated with any of the commercial companies or any of the actual developers of the Russian crypto algorithms. So it's just my spare time project, and for some part of the history it's quite important because I view it not from the developer's point of view, but from the user and software developer point of view. So the word GOST means government standard. There are standards for a lot of things, starting from the food, from building, from construction, and in the last 20 years we have started to have standards both on the crypto algorithms. Yeah, just like NIST. Russian crypto algorithms have developed the full set of crypto primitives and crypto algorithms on top of that. Yeah, just like NIST, just like the rest of the world. We have digital signature algorithms based on the discrete logarithm problem on the elliptic curves. We have symmetric encryption algorithms, and we have hash functions. On top of those standards, yeah, those are standardized. We are building a set of the recommendation for the standards, amendments for the current crypto standards, like those that you use in everyday life, like public key encryption, the certificates, cryptographic message syntaxes, and all PKCS extensions. And last but not least, and one of the most important topics, is the CLS extensions, TLS cipher suites. And I will come to these a little bit later. So let's start from the kind of history. Yeah, I promised to Nikos some kind of myth busting. I will not be going into real deep technical details. If you want, we can speak about that after the short talk. So the first myth: crypto algorithms are all invented by the Russian secret service agencies to be able to undermine the crypto algorithm users and to be able to actually read Russian email, read and assign all the Russian opposite sides, certificates, etc. No, that's not actually true. So the initial set was developed really by the Secret Service, but for the last 15 years, the crypto algorithms are developed more by the commercial companies. Yes, they have license from the FSB, but they are not the agents. They are just security engineers like we are. GOST crypto algorithms are unsecure, thanks to the works by Nicolas Courtois and by mostly by him. It's a common word in the EEC that, okay, it's easy to break GOST crypto because once you have 2 power 64 ciphertext and plaintext pairs, you can get the key in 2 power 224 operations. Yeah, that sounds true, but once you have 2 power 64 plain ciphertext operation pairs, you do not need any more the key. You have the dictionary. And in fact, up to, according to the current cryptanalyst results, all current standards are safe because, well, we have to use them by law in the current, for the secure information. And if there will be any insecurity, if there will be any actual cryptanalysis results, our commercial companies will be against using them. And so for now, we are safe. And last, one of the most important myths that is brought regularly into the IETF meetings when another guy tries to write an RFC about the Russian, Chinese, Japanese, any other crypto standard. Okay, the rest of the world does not need the national national crypto standard. We already have AES, we have the SHA, so why do we need your crypto standard? Why do we need another SM primitive, GOST primitive, camellia seed, you name that? Well, first, we need crypto agility. If we all live in the AES and SHA world, we lower the possibilities to actually create new things, to create diverse software that will support more than just AES and SHA. And if sometime in the future there will be an interesting cryptanalysis result for the AES, for the SHA, well, we will be doomed because the software will not be able to be updated. We have seen that several times when software was just using the SHA1, and now with the advances in the generation of collisions for the SHA1, though that software authors have started thinking, okay, how can we upgrade if we did not embed the actual property that is SHA1? So crypto agility is important. Second, it's a full stack alternative. If you do not trust American standards, you can use this one. You can use them together. You can use any combination of the GOST and NIST standards, whatever you would like in your own software. Again, this is just another full set of primitives like the Chinese guys did, and they're bringing that to the OpenSSL and the rest of the crypto software. And more importantly, as we open the path to the Russian crypto, to the IETF standards, we have started seeing more and more interesting ideas and important ideas generated by the Russian crypto community, by the Russian crypto engineers. I would name several of them. One of the Recane for the symmetric crypto, for the symmetric crypto encryption, for the symmetric keys. That means that once you use a predefined amount of the plain text, you should rekey, you should change your key in the unpredictable way, so that there is no possibility to have an actual dictionary attack, to have the twins attack on the plain and ciphertext amount that you have generated. The multilinear Galois mode, MGM, and all I'm naming are the current IETF drafts. The MGM is an alternative to GCM mode. It has the lower throughput compared to GCM, but it has more strong it is more strong compared to the GCM. It cannot. It uses the encryption both to actually encrypt the plain text and to generate the MAC value, and so it is not as susceptible to the possible attacks as the GCM is. TLS external Recane. This should be most probably interesting to the in comparison to the previous talk and to the TLS users, because it actually allows you to and enforces you to change the TLS keys that are used to encrypt and to MAC each of the messages, or each set of the messages, in progress of the TLS transmission. And the another one of the password-authenticated key exchange protocols, the CSPA key. This is now published as an RFC, and you can also use that. It was invented by the Russian crypto engineers. Okay, the OSS port. Why do we need it? Why do we want it? Why do we work in our spare time to provide the open source support for the GOST? It provides additional tests. It provides additional test cases and test situations. In the GNU TLS and the OpenSSL, For the OpenSSL, it is quite important because GOST crypto was initially created as the separate GOST engine, and Dmitry and Titus Wagner from the Crypto.com have faced a lot of the issues with the actual external engine supporting the OpenSSL. GOST engine was and is used for quite some time as the main test case for the external engine support in the OpenSSL. GOST support provides us a way to replace commercial software. As I said, in Russia, it's mostly developed. GOST support is mostly developed by the commercial software vendors. It's closed source. You cannot get the source. You cannot read what's inside. And if you want to check the signatures, if you want to read the encrypted data, you have to either use that commercial closed source software, or you have to write your own support. For example, to check that the signature on my ham radio license is valid, I had written support for the GOST signatures in the GNU TLS. That's just to verify that my ham radio license is valid. And last but not least, it's fun. So the current status. OpenSSL, it was the primary target by my colleagues. It is supported since 2004, 2005. It has a really long history because to actually support the GOST algorithms, the GOST digital signatures, my colleagues had to invent and to enforce the use of the algorithm-neutral API for public key encryption in the OpenSSL. So that was a really long-term project for them, but they were successful. And nowadays, OpenSSL has the algorithm-neutral public key functions. You can use them, and you should use them for accessing the public key function instead of the individuals encoding. Okay, this uses RSA, this uses DSA. This is elliptic curve digital signatures. Oh, and nowadays you have another set of public key encryption, and you have to add this, and you have to add this. Oh, and this goes more and more into a nightmare. LibreSSL, a fork of the OpenSSL by OpenBSD guys, they have thrown away most of the engine support. They have thrown away the external engines. So when that fork started, we had to actually rewrite the GOST engine piece of code into the core LibreSSL functionality. And LibreSSL was one of the first major crypto libraries, to actually open source crypto libraries, to gain the full GOST crypto support. GNU TLS, another major TLS implementation. Currently, it has the public key support, it has the signature support, and for the TLS, the patch set is ready. It's waiting on the GitLab as a GitLab merge request on the GNU TLS side. We are waiting for the IANA numbers to be assigned to the actual TLS cyber suits, so that we'll not be just using the private numbers in the final open source software, but we'll be using the assigned numbers, and we will be using that as the main test suite to cross-check the OpenSSL and GNU TLS support for that. libgcrypt, software created by Werner Koch, another low-level library. It doesn't have TLS, it doesn't have actual PKCS, it's just low-level algorithms. And it was one of the first targets by me to write GOST support, because it allows us to use the GNU-PG with the GOST. It allows us to use the rest of the software with GNU-PG without actually having to implement it in the Cleopatra, in the rest of the KDE, rest of the GNOME software. XML signatures for the XML. There's there is an RFC on that, and there is support in the XML sec library. That was the Braid part. Right. Okay, on the other part, the crypto library that is used by the GNU TLS and by some other projects, the Nettle library. Unfortunately, the patches do exist. The patches were accepted in the GNU TLS tree, but the NATO is slow in accepting them. So GNU TLS is using them. Has the necessary code bundled instead of using the part of the NATO library. Boring SSL, yeah, another boring story. Neither my colleagues nor me had time to port the OpenSSL code to the boring SSL, to another OpenSSL fork. It should be easy, and it should gain us the GOST support in Chrome and Chromium, but it is not yet done. And we don't expect any serious problems except the code acceptance in the Google tree. NSS, the very famous and very big crypto library, it was the former standard for most of us. The patches do exist for a really long time, since 2005, I think, or 2006. But the Mozilla guys are very slow and very reluctant and resistant to accepting them, mostly because they do not see the need to have another national code, and because of the issues with the quality of the patches. Well, they work, but they are not accepted. Bind9, DNSSEC, you know that. Well, there is a GOST RFC on the DNSSEC. The RFC is old. It uses the old and obsolete GOST algorithms, and Bind has dropped the support for the GOST encryption. We should be updating both the standard and the Bind9 with the new algorithms. And last but not least, there is no open source IPsec software that actually supports Russian crypto. We are working on that. There is a plan to write a new set of standards on the IPsec using the AAD algorithms, by using AAD mode, but currently there is no IPsec. Yeah, last but not least, my marketing department has insisted on inserting this slide, so yeah, thanks to them for allowing me to come to FOSDEM and to speak to you. So that's all for now that I wanted to talk about the GOST crypto. I did not go into technical details in my talk, but if you want, we can discuss that either right now or later. So, any questions?
Any questions?
Hello. So I don't know if this is a bad question, but can you share your thoughts on Telegram?
Sorry?
What about Telegram?
Well, we are using 4G and 3G that are developed by major vendors. There is, as far as I know, there is no specific set to encrypt the 3G, 4G, 5G messages. So there is no special phone encryption. No. The backbone uses the famous SS7 protocol, and so you do not have to really change the encryption if you can tap into the phone providers by law by using the infamous SORM system for operation investigation matters, which you have to install if you are the internet service provider or the telecom provider. So there is no special set of crypto standards.
Yes, a question about have you had any pushback from NIST or other government organizations, pressuring people not to accept the GOST standard?
Not as far as we know. So, in fact, most everybody creating their own national standards, and NIST is one of them. NIST and NSA is pushing for accepting national standards, because accepting Russian standards into IETF is a way to also accept NSA standards into IETF. Okay, so it's not good, it's not bad, it's just another argument for them. So they do not recommend using that, of course, because they have their own set of recommendations, but there is no real pushback.
Hello, thanks for your talk. I wanted to ask how much comparative cryptanalysis has been done on GOST compared to the NIST submissions?
Of course, the amount of cryptanalysis is much lower, and the amount of public cryptanalysis is much lower compared to NIST. I do not have a full list of references to the cryptanalysis with me in this slide set. We can talk about that afterwards. I have on another set of slides created by one of my colleagues. All the algorithms have received the cryptanalysis both internally and externally.
Any other question?
Do you have any information comparing to AES, RSA, SALSA, CHA algorithms in terms of comparison tables or benchmarks? What is better? Other benefits?
Yeah, if you compare to the AES, it's quite interesting because if we do not use AES and I instructions, the comparison will be much par and par because we use the more or less the same constructions everywhere, both AES and the latest icons Kuznechik grasshopper. But if we allow one to use the AES and I instructions, if we allow one to use the PCL-MALD, a set of instructions specifically written to support ultra-fast AES. Yeah, of course, AES will be one decimal order, at least faster than compared to the grasshopper. The implementations that merged into the libgcrypt, into the GNU-TLS, into the librsSL do not have any assembly optimized instructions, so it's plain C. You can use that to actually understand the algorithm. You can use them to actually check what's working and how it's working, and to actually analyze the set of the instructions, the set of algorithms. And of course, you are open to write the assembly in an optimized way. The OpenSSL engine has received some parts of the assembly optimization, and it is now getting closer and closer to the AES implementation of the OpenSSL.
Okay.
So something that I always wonder about, like the stuff like the GOST cipher suite, is the following.
Sorry?
There are 8 countries in the world that have a larger population than Russia. There are 11 countries in the world that have a larger GDP than Russia. What if all of those countries also had the same idea of coming up with their own crypto suite? Would it be desirable for something like the public internet for all of them to also be incorporated in crypto libraries? That would fragment the internet quite heavily, right?
I couldn't get the last phrase.
Oh.
Sorry.
Oh, I'll repeat the question. Sorry, I'll hold the microphone a bit closer. So there are 8 countries that are larger than Russia.
That, so.
11 ones that have a larger GDP. What if each of those countries also made their own crypto algorithms and also put laws in place that require the use of those crypto algorithms in their country? Would that be a workable situation for the internet as a whole?
I do not think that it will make the situation worse. Chinese government agencies are currently pushing the SM2, SM3, and SM4 signature, hash, and encryption standards into the major crypto libraries. I do not know about India. Well, we all know about the United States, and that NIST and NSA are pushing their standards through the open benchmarks or just through the RFCs. So things will not be worse. You do not have to actually use them. As the system administrator of the server, you do not have to allow all the crypto algorithms. In fact, nearly all web services will probably have the limitation for the server suites in the configuration file to use only a specific set that this sysadmin of them sees as strong enough and good enough to be supported on that web server. So no, this doesn't open a can of worms. This doesn't open a full set of the 8, 9, 10 crypto algorithms. Japan has tried creating the Camellia and related set, but they have mostly stopped doing that, and they have, I think, mostly stopped enforcing the use of the Camellia in the open internet. So there is Camellia GCM standardized, but it is not actually used. So again, if we support these, if we allow one to use these primitives, it does not enforce one to use them. It does not enforce and it does not allow you to use them by default because you will not be allowed to connect, for example, to the google.com by using the GOST ciphers.
So let's all thank Dmitry.
Yeah.